Okay, so even with off-highway and any sort of agricultural equipment and construction, marine, we are all still using CAN bus. It's still very much a big part of the network structure within these machines. Some of these are even more complicated than most vehicles in the automotive world that are out there. So, networks are a big thing. One of the interesting features within these CAN bus networks is that they typically use something called J1939 protocol. Whilst we have our generalized automotive CAN, which is typically called J2534, J1939 is much more standardized. Now, that doesn't necessarily mean that every manufacturer uses the same bits of information, but there is a standard list that most of them will adhere to. Now, what that means is that we can do some clever stuff within our software. And that's mainly thanks to the software teams introducing a new decoder, which is the J1939 decoder. That actually breaks up a portion of the header of the packet of data and puts it into 3 columns. The columns are the priority, the PGN, the parameter group number, and the source address. I can't stress how important the source address is when it comes to fault finding. It may be that there are several gateways between your serial tool and the network that you are looking at. So how do you determine whether or not there's a problem with the network or a potential problem with the gateway? Well, this is where Pico can be really helpful, because by decoding that J1939 network, getting those source addresses, we can see which ECUs are online and which ones are not online. Now, I've picked quite a fairly basic one here. So underneath here, we actually have one of the knock sensors for the after treatment system. Now, I've literally just backpinned into the CAN high and CAN low signal on there, and then that will give us our information. So it will give us our raw voltages. We're not going to do anything massively different with how we capture. So there is a guided test for J1939 decoding, which we will load in. Once we have that loaded, it will give up our references, our known good, what we typically look at. It will give us our mass channel, and it will also give us our decoder. Now, most of the time, J1939 sits in 250 kilobaud. It is now moving to 500 kilobaud as well. So it may be that the decoder, which is defaulted in this case, in this guided test, to 250, it may be that if you are getting data that isn't decoding properly, you need just to change your settings to 500 kilobaud. Okay. So the guided test is already set up. It has done our settings for us. It has created the mass channel for us as well, so that A minus B. We're going to go ahead and we're going to go and start the scope capturing data. Now the ignition is on, so we should start to see our data coming in. And as you can see, the maths channel, obviously maths is only ever updated when we're in streaming, once it gets to the very end. And we can see our data and our list coming up. So I'm just going to stop the scope there for a second. We'll just go back a couple. Now, as we can see in our table, one thing to be aware of is the order that it goes into. If it's not in numerical order, just click the packet number and that will automatically put it into a list that is more reflective of what was going on. One of the key differences is how we've set this decoder up in this guided test is we've put the format into decimal. Now, decimal is a different way of viewing it. Typically, it's usually hexadecimal, but you can usually find parameter group numbers listed in a decimal value. There's a fantastic website out there called isobus.net, and on there is actually a standardized list of all the PGNs that are potentially out there. Obviously, there will be proprietary ones on certain machinery. Of course, there will be. They have to protect some of their data. But for the most part, you can get a lot of this stuff. So the source addresses are also on there. Now, that's important when we come to look down the third column, which is our source address. And we can start to see that in this case, again, it's on the after treatment side, so it's a smaller network. There aren't as many ECUs on here. Now, being slightly sad and spending far too long looking at decoding J1939, I can already tell you that the source address 0 is for the engine controller number 1. So automatically I know we've got our engine ECU. 82 is actually one of our knock sensors, as is 87. And 41 is our after treatment ECU. So straight away I can see that there is 4 ECUs that are on this network. Now there is another little trick that we can do within the software, which is something called link files. Because we now have this standardized list that we can find, we can actually create a link file using the template from within PicoScope 7. We can create the link file externally, and when we apply it to the decode table in PS7, that will now change those values into a human-readable form. What we're going to do right now is we're going to use a little bit of magic, and we're going to cut to myself talking through how to create link files and how to import them into PicoScope 7.
Okay, so we're going to take a look at link files now. So what we're going to do is I've taken some J1939 decoded data, and obviously I've used the test, so let's set up the mesh channel for us and set up the decoder as well. Obviously, one of the things I mentioned in the video was that if you have an incident where the data is not decoded, you may need to change the baud rate. So to change the baud rate, if you click on this icon over here, you get the configuration set up for the J1939 decoder, and in there you have the baud rate. So it may be that you just need to change it to 500 kilobaud. A real quick, easy way to check what your baud rate is, if you go into a packet, so let's take this example here, and all we're going to do is take 2 time rulers and measure one of the smallest pulses. Now this can either be in any direction, it doesn't matter, so just literally the smallest gap. So here obviously we can get a bit closer as well, but you can see there that that's pretty much in the 250 kilobaud mark. So yeah, if I wanted to zoom in a bit and get that even closer, I'll see on the 2 edges, there we go. So 250 kilohertz is equivalent to 250 kilobaud. Okay, right, zoom all the way back out again. So providing that we have all of our decoded data listed underneath. Now, as I said in the video, I have mentioned that this decoder is set up into decimal. The reason being, obviously, is that PGNs, they typically come in a decimal format, and it also means the source address will be in a decimal format as well. The website I mentioned was the isobus.net website. So here we have the website. It's automatically, I've just clicked on addresses, and here we have all of the predetermined isobus source address IDs. These are typically standardized, and what you'll find is that there are different industry groups which obviously have different, they do change some of the source addresses depending on which industry you're in, so be mindful of that. If you just click on the different ones, they will just bring the ones that are different. So for this example, these IDs, these source addresses are similar to ones that exist in other industries, but obviously they have different names. Okay, so all we're really going to get interested in to start with is the global, so applies to all. Straight away you can see that there are some very obvious ones at the top. So what we're going to do is we're going to take a few of these, maybe we'll just take 2 or 3, and you just give you the idea about how to set the link file up. So if we go back to PicoScope, here we've got 0, there's 3, there's 15, so we'll take those 3 as the first ones that we're just going to apply a link file to. So if you click data to text and then create a template, it's going to ask you to set that template somewhere. So all I'm going to do is I'm just going to put it on the desktop. So we'll call that J1939 source address. And I'm just going to put decimal at the end, just in case if you were working with other templates, you want to make sure you're working with the right one. So decimal just means keep everything in decimal format. Click save. Right, okay, now what we need to do is open up that file. So if I just go to our desktop, what I'm going to do is open up this Excel sheet. So it should hopefully open up in Excel, and we should be able to start editing this template. Let's drag this over. Okay, so now we should be able to make some relationships with the decode table and the headers in this link file. So the ones that we're really interested in are things like the source address and the PGN. So we're just going to start with our source addresses just because in my experience they are the most useful one. So all this is a lookup table. It's nothing different. It's nothing more special than that. So all I want to do is I want to say, right, if my source address is 0, I want the software to return the description as, again, if we just quickly nip back to our isobus directory, engine #1. Engine #1. Okay? Very, very simple like that. One of the other ones we had was 3, so we're going to use transmission number 1 as well. So transmission #1. And I think there was 15 as well, wasn't it? Let's just quickly jump back in. Yeah, 15. Okay. 15 is retarder engine compression braking. Okay. So back to our link file. So 15. My mind's gone blank already. Retarder engine. Okay, we'll just keep those as those 3 for a second. Right. Make sure you save it. And then we're going to close the software down. Now, the only reason being is that I have found in some instances it doesn't always update. If you make a change, save it, you have to keep going in and out of the link file. It's just more of a process for me. So I'm just going to close the Excel sheet for a second. I'm going to go back to PicoScope. We're going to go data to text, and then we're going to click open. So hopefully it will find our J1939 source address. Click OK. We'll see you work through all the different decoding sections, and then there we have it. So we've changed 0 into engine, 3 into transmission, and 15 into retarder for engine. So you can now start to see how that can be useful if you're trying to trace down ECUs that are potentially offline, or like I said in the video, if there are particular gateways. Obviously the benefit of Pico here in this instance is that you can go anywhere. All we're doing here is actually just hopping into the CAN high and CAN low, and then obviously decoding that data from there. You might not be able to do that with your scan tool if there's not a serial port on every network. So this is just a quick way of just determining whether or not you have actually got traffic. Using the J1939 decoder, we can split that header up into the 3 columns, and then you can use the source address here to actually determine which ECUs you have present on that network and which ones aren't. The same thing applies with the PGNs. Obviously on the isobus website, there is actually a PGN section. And again, you can do exactly the same format with your link file. All you need to fill in is the number that you're going to use. So one that's quite common is 61444, which is for electronic engine controller number 1. So if you have this number, you put it in your lookup file. Obviously, you can change the description to engine controller 1, and then in your lookup table, you will actually have, so this very top one, for example, 61444 would now say engine controller number 1. All right, I hope that helps. If there's any sticky points with that, or if you want to ever look for some more information, don't forget under the support material, there is actually our A to Z PicoScope. In there is a section on J1939 serial decoding, which will take you to a link on our website. Within that website, there is an animated GIF, which can also talk you through how to set the decoder up, and also a bit about using the link file and how you can change the values into readable data. Okay, I hope that helps, and thanks for watching.